Hi, my name is Guanglei-Ma, and this is my project report of the optimization. My problem is about the kitchen arrangement optimization, and here is my coordinate structure. And for example, if the orange point is my position and the blue point is my target source, so to grab it, I need to take one step to the right and raise my arm to reach it. And by calculating the energy for each action, I can get the total energy to grab the sauce or spice I want. So my optimization is about how to rearrange the spice position, so I can use the minimum total energy to cook all the dishes I want. So first I build up a dishes spice table like this, and then I get the spice total use matrix as. And here is my fixed coordinate blocks. And by inputting the energy for each kind of action, I can calculate the energy consumption to reach each block. And then I can get the energy matrix E. So the total energy is the matrix S multiply matrix E. And by switching the order of matrix S, I can simulate different spice arrangement and get the corresponding total energy. But what I want is a fixed S matrix and fixed E matrix. So here I introduce a variable X. By multiplying the S matrix and the X matrix, I can switching the order of the S matrix. And the point here is the X matrix is a pseudo-like matrix. So every line sum equals 1 and every row sum equals 1. So all the atoms in the S matrix will appear only once. One times. And then I can start to build up my object function. The total energy is the S matrix multiply X matrix multiply E matrix. But what I want is the object function A multiply X. And the X matrix here is composed by 441 variables. And I can directly expand the S multiply X multiply E. And because it's a linear polynomial, so I can pick up the coefficient of it and get the A matrix. And then I can build up my object function, and here is my code. Then I start to build the constraint function. The constraint for X matrix is every line equals 1 and every row equals to 1. So I write two loops to set up the constraint for the line and for the row. Then I can start to optimize it. Because it's a discrete variables problem, so I use the integer linear program to do optimization. And after that, I adjust the format and show the result. And here is my result like this. And by taking reference to the spice matrix, spice table, I can figure out where is each spice. And here is my final optimal arrangement and my minimum total energy. So after all, I can get my optimal arrangement for the kitchen. And that's all for my project. Thank you so much.